Hi, everyone. Just wanted to take a minute to talk a little bit about area, in particular, the area of triangles and quadrilaterals. So, we're going to kind of start with a broad overview of them. They're relatively straightforward and things that you hopefully will have seen before in terms of what we're looking for, just to make sure you can calculate and things like that. Um, but to start off, we have the area of a triangle. Now, the area of a triangle is 1/2 base times height. Just the only thing that you have to be careful of is that the height is an altitude. Okay, so just don't forget that the height, oh geez, is an altitude. Okay, so that is a right angle. Um, and the other benefit of this is just kind of looking at this, you can almost see that, like, if you piece it together, right, like another one like that, you're going to get a parallelogram. So you can see kind of how this all is interacting together to once you get into parallelograms and why it'll just be base times height. But just a quick note, obviously, because this is a right angle, if you look at it, right, you can kind of look at, see our angle theta. You have an opposite, and if you know this side, right, you can use sine to actually find the height as well. So if you do need that, you can find um, the height of a triangle using trig. And there are a couple other formulas. So this is the one I was just alluding to with the trig, where obviously it's 1/2, base times height. Or alternatively, if you need to find the height using trig, it would end up being sine. All right. And in terms of if you're given no additional information about the height and you don't use trig, there's this thing called Heron's formula, which uses the semi-perimeter. We're not going to focus a lot on that, but just know of its existence. This is something that if I asked you to use it, I would provide you with the formula, just because it's a little hard to kind of off the top of your head remember, but it all can be pieced together using, if you derive it, it'll all work out. All right. Now, additionally, we have the area of different quadrilaterals. So I think everybody's familiar with a square, the two sides multiplied together. So you get the side length squared. A rectangle and a paragram are both base times height, or length times base, base times width. Regardless, they're all the same. As you can see here, the parallelogram is very, similar to like two triangles, right? You can see, right, triangle, triangle. So it makes sense as to why this is just double the triangle formula, because you have two triangles. And kind of using that same thought with the trapezoid, right? You can break it into, um, two triangles and a rectangle, or sometimes you don't necessarily need the two triangles, but a triangle and a rectangle at the very least, and can use that to derive exactly where this comes from, where you have 1/2 the top plus the bottom, so base 1 plus base 2 times the height, when again the height is almost like the altitude, if you will. And then the rhombus and the kite actually have the same formula. Their formula is 1/2 times the diagonals multiplied. Um, Now, again, this is just coming directly from if you were to make 4 triangles, right? So if you made 4 triangles, what you can end up doing is, this part is half the diagonal 2, this, half a diagonal 1. So you essentially have 1/2 the base, which is, half of diagonal 2. And then, half of diagonal 1 is the height. So this is essentially 1/8 diagonal 1, diagonal 2, but there's 4 of them. So times 4, and that's where that formula comes from. Same thing with the height. So realistically, if you don't remember them off the top of your head and you're not provided with them for whatever reason, most of them, except for the rhombus and the kite, are provided on a reference sheet for MCAS. But if you needed to derive them, just break it into shapes you do know. All right. So just a quick practice. Okay. Right. So if we needed the area of this parallelogram here, we could figure it out. So if this is 11 and this is 5. Obviously, the base is 11, but we don't know the height. We need to find it. So we know this is 5 because this is a parallelogram. So this is also 5 meters. So you actually have a 60 triangle where the hypotenuse is 5. So this is 2.5, or 5 halves. And this would be, 2.5 root 3. So that's where that comes from. So the height is 2.5 root 3 because it's a 30, 60, 90 triangle. And we have times 11. So 11 times 2.5, or 5 halves. So it would be 55 over 2 root 3. And don't forget your meters squared, which, again, depending on how you set it up, could be a fraction. Okay, the triangle, we have 1/2 the base, which is 25. Again, you don't need to add in this 15, times the height, which is 17. Now, I don't know what 17 times 25 is off the top of my head. Oop, I don't apparently plug it in right. So it'd be 425 over 2, and again, that's centimeters squared. Okay, this is a height, so the area would be 12 times 14 over 2. So 12 times 14 is 168. 168 divided by 2 is 84. Don't forget your units. So same thing with this rhombus here. Just be careful because you need the whole thing. So it's not, the whole thing's not 5, the whole thing's 10 times 16, 1/2. So that'd be 160 divided by 2 is 80. All right, and then finally we have our trapezoid. So again, it is 1/2 base 1 plus base 2, so 29 plus 9.5 times the height, which is 23. So 29 plus 9.5, I don't know why I just did that on calculator. It'd be 1/2 38.5 times 23. Oh, running out of room. So divided by 2 times 23. When you plug that all in, you should ultimately get 442.75 centimeters squared. And don't forget your unit. So overall, these should be relatively straightforward and simple. I'm hoping that most of them are a review for you. But if not, here they are as available to you. And let me know if you have any questions. Have a great day.